capacitance and how, when the capacitance is connected in series, how we will find out the equivalent capacitance. Similarly, when we will connect in parallel, how one can find the capacitance equivalence. Also, we are going to learn about energy stored in the capacitance as well as energy stored in the inductance. First, let's see about the capacitance. See, this, whenever the two parallel plates are separated with some dielectric material, the capacitance effect will be come to the picture. So, if we are giving this voltage across this parallel capacitor, parallel plates, automatically the capacitor will start to charge in the electrons will charge will be stored in this capacitor plate. Whenever the supply is terminal is connected to the any load, that battery will that capacitor will act as a energy source and it will provide the energy to the load. So like that we have learned. Already we know that capacitor, inductor and resistors all are passive elements. The passive element in the sense it is not the any source. It will not be the starting itself, it will not act as a source. Resistance will dissipate the energy, so that is a passive element. And inductive element, inductance and capacitance all are absorb the energy and later it will release, but it is not as a actual active energy source. So both three elements are resistance, inductance, capacitance, all are the passive elements. Normally when the capacitor is two parallel plates are separated with the distance of d, we can see the capacitance is equal to epsilon A by D. We know already capacitor unit is farad, right? Even short form we will write it as symbolically F, right? So here the capacitance C is nothing but epsilon A by D, wherein epsilon is equal to permittivity in farad per meter. The epsilon can be, area is nothing but the area of the plates. A is nothing but the area of the plates in meter square. So epsilon is normally epsilon naught in the epsilon r, and epsilon naught is called as permittivity in free space. That is, the value is 8.854 into 10 to the power minus 12 farad per meter. And relative permittivity, epsilon r is nothing but relative permittivity of the dielectric material. We should know what are all the different materials. Dielectric material is having different permittivity. For example, air, the relative permittivity is 1. If you go ice, the relative permittivity is 3 to 5. Water, this relative permittivity is 81. So which type of dielectric material which we are using here, accordingly we have to select the epsilon. That's why we from this we can understand how one can select the epsilon r based on the dielectric material. Normally the symbolic representation of the capacitor is like this, positive and below negative. We can use any way positive this capacitor symbol. This is for your understanding how the capacitor is used. So when these capacitors are connected in series, already I told you for convenient purpose I am taking as a box. Normally in electrical we will call it as this box is impedance. So assume that this impedance is having only the capacitance. So the two capacitance are connected in series. So automatically that capacitance equivalent will be calculated 1 by C equivalent equal to 1 by C1 plus C2. It is just reverse of inductance and the resistance. 1 by C equivalent is 1 by C1 plus 1 by C2. Already we know how to find out C equivalent. We have already gone through resistance and inductance. So C equivalent is equal to C1 C2 divided by C1 plus C2. Now when the three capacitance are connected in series, C equivalent equal to C1 C2 C3 divided by C1 C3 plus C3 C1 plus C1 C2, right? If suppose when the n number of capacitance connected in series, we can write 1 by C equivalent equal to 1 by C1 plus 1 by C2 etc. plus 1 by Cn. Assume when the two capacitance are connected in parallel, when two capacitance are connected in parallel, just reverse of inductance and resistance, the C equivalent equal to C1 plus C2. Then if suppose 3 resistance as 3 capacitance are connected in parallel, C equivalent equal to C1 plus C2 plus C3. If when n number of the capacitance connected in parallel, so C equivalent equal to C1, C plus, C2 plus, C3 etc. plus Cn. I hope you understand what is the effect of capacitance, what is the formula for the capacitance. Already we know capacitance equal to Q by V, right? So we are going to be do it in the next slide, how we are going to be find the energy stored in the capacitor and inductor. Now we are going to learn about what is the energy stored in the capacitor and inductor. First let's see about the capacitor. So the current flowing through the capacitor is nothing but dq by dt. We know current is nothing but movement of charge with respect to time. So the rate of change of, otherwise we will call it as the rate of change of charge with respect to time. So IC is equal to dq divided by dt. Q is nothing but the charge, T is the time. So from this we can write IC, already we know C is equal to Q by V. From this we can write Q is equal to CV. Just we are substituting here IC equal to D by dt of C into V. But from this C is the capacitor. Assume that C is constant. Therefore IC is nothing but C into dV divided by dt. Already we know the power is nothing but voltage across the capacitor in the current flowing through the capacitor. In previously when we study Ohm's law, we have seen power dissipated by the resistance is nothing but voltage across the resistance multiply with current flowing through the resistance. Similarly, voltage across the capacitor multiplied by current flowing through the capacitor. Therefore, we know IC is nothing but C into dV divided by dt. So we can write IC equal to C into dVC divided by dt. That means voltage across the capacitor VC. So we can write P is equal to VC into C dVC divided by dt. So now we can take this dt in the left hand side. So we will get P into dt equal to VCC into dV. Then what is mean by energy? Energy is nothing but the power into time. That means power consumed or energy stored, power stored by the any element in the particular time period. So that we are going to be integrate now so that just we are modifying this equation. P into dt is equal to C into VC into dVC. So C is constant. So when we integrate it, integration of P into dt equal to C integration of VC into dVC, we will get the final value as energy stored in the capacitor is half CVC square. Otherwise normally we will call it as half CV square. So with this we can understand what is the energy stored in the capacitor. Then let's see about the energy stored in the inductor. From the electromagnetic induction, we know that induced EMF E is equal to, or V is E or V, induced EMF and voltage all are unit is same, volt. So induced EMF is equal to N into d phi divided by dt. I am taking N inside, therefore d is equal d by dt of N into phi. But we know that L into I equal to N into phi. That means inductance into the current is equal to number of turns into the flux. That means current is flux is directly proportional to the current flowing through the inductor. Therefore, from this first equation, we know that we are going to be substitute here the value. So V is equal to L into di divided by dt. That means N in phi we are substituting L into I by N. So N will cancel. So we will get V is equal to L into di by dt. So the power in the inductor, how we can write similar way of the capacitor, voltage across the inductor into current flowing through the inductor. Now we are going to be substitute, already we know voltage across the inductor. Here also instead of V we have to be write VL equal to L into di divided by dt. So we are substituting here VL value L into di divided by dt. Then the same way P into dt equal to IL into L into DIL. Then we are just rearrange, we can rearrange this equation. P into dt equal to L into DIL, L into IL into DIL. Therefore, when we integrate it, we will get the final value of energy stored in the inductor is half L I square, or otherwise half IL square. That means inductance in half into inductance into the square of the current flowing through the inductance. I hope you understand. So from this we understood what is meant by capacitor. Capacitor is nothing but C is equal to epsilon A by D. The capacitance vary, if the capacitance value will be vary based on the dielectric material which we have used. Then if the capacitor is connected in series, we can write 1 by C equivalent equal to 1 by C1 plus 1 by C2, etc. Then if suppose if the capacitance are connected in parallel, we can write C equivalent equal to C1 plus C2, etc. Then energy stored in the inductor we can calculate from C is equal to L half CV square for capacitor, inductor half Li square. From this slide we will understand what is the voltage across the inductor also. What is the voltage across the inductor? V is equal to L into di divided by dt. What is the current flowing through the capacitor? IC equal to C into dVc divided by dt. I hope the topic is understandable and interesting. Those who have not subscribed this channel, kindly subscribe and share to your friends. Wish you all the best. Thank you.